In this lesson, we are going to be looking at some applications of sinusoidal functions. So in these problems, what we're going to be doing is you're going to be given a scenario, and you're going to have to draw a sketch of the sinusoidal function, and oftentimes write an equation. So in example 1, we've got Megan getting on a Ferris wheel that has a diameter of 30 meters. She gets on at 3 meters from the ground and completes a rotation in 60 seconds. Find the equation of cosine of her height versus time. So, and then show a sketch. So we know that she's getting onto the Ferris wheel at a height of 3 meters above the ground, and the diameter of this Ferris wheel is 30. So we can assume that that is 30 meters from like the bottom of the car up to the top of a car. So this is a diameter of 30 here. So if we take that 30 meters plus the 3 meters above the ground, it means the total, the highest peak that these riders on this Ferris wheel go to is 33 meters. So if we think about starting to graph that, you would have a minimum height of 3 meters and a maximum of 33. Now the amplitude in this case is going to be the distance from the middle to the top or the middle to the bottom. So because that diameter is 30, that means our amplitude here is 15. And the K value would be that 15 meters plus the 3 meters above the ground. So the middle here, when you're at the middle of this Ferris wheel, would be at 18 meters. Now it says that this Ferris wheel completes a full rotation in 60 seconds. So that means the period is 60. So 2 pi divided by b equals 60. If you solve here, remember you would do 2 pi over 60 equals b, because these can just switch places. So our b value would be pi over 30. So if we were writing this as an equation, we have y equals, our amplitude is 15. It asked for a cosine function. So cosine of, what's the b value? Pi by 30. We don't have an indication here of a shift, so I'm just going to leave no shift, but then a shift upward, sorry, I should say a horizontal shift, but then a shift upward of 18. Now when you go to graph this, the thing about writing these equations is that you often want to graph them and then check your equation, because oftentimes the starting point can kind of make a difference. And in this case, you'll see when you graph this, she starts at 3 meters above the ground, goes up to the peak height at 30 seconds, and then back down at 60 seconds. And as a cosine function, you'll see that this is actually reflected vertically. So this would also just need a negative. That's why it's really important in these situations to graph it, because you can get your amplitude, your K value, your period, even your shift side to side usually just by reading the word problem. But sometimes you might miss the fact that here she's getting on the Ferris wheel at the minimum, so it starts down at 3, meaning that there is a reflection. Remember, when you're drawing these graphs, really important to label. So this was height versus time, so just make sure that you're labeling both of those things. So Ferris wheels, very common application. Another common application, this is hours of daylight. You're going to see that there's only really a few different applications that you'll come across. Now in this case, this is telling you that this graph is showing the number of daylight hours. So here is the number of daylight hours against the day of the year, down on the bottom, for a caloid. The graph approximates a sinusoidal function whose equation can be determined. Find this sinusoidal function, and what assumptions did you make? So if we look at this graph, you can see that you sort of have to approximate. But if you look here, you can see the minimum looks to be at around 4, and the maximum looks to be around 20. So I used a ruler just to draw in a dotted line to sort of help you find that minimum and maximum. And then that means the middle is actually quite a lot easier to find. It's at 12, so that's your K value. So here we have an amplitude of 8. Now, what we can also assume when we're looking for the period is here we have 1 full year, right? So this goes April and then it ends at March, so that would be 1 full year. We can use 365. We're assuming this isn't a leap year or anything like that. So the period is 365. That means 2 pi over b equals 365, which means the b value is 2 pi over 365. So when we go to write our equation here, now remember it just asked for sinusoidals, so you can write it as either sine or cosine. This graph, most definitely, sine is going to be the easier option. You have 8 as the amplitude, sine of 2 pi over 365 of t. So the reason that we're using t is because that's what's used on the axis in the graph that was given. And then plus 12. With a sine graph, we have no horizontal shift. If you wrote it as a cosine graph, you would have a horizontal shift, which would be really tricky to determine here because you're working in months. That's why sine is going to be your best bet. Now, example 3, another common example, we have the petals on a bicycle. So the petals on a bicycle have a maximum height of 30 centimeters above the ground and a minimum height of 8 centimeters above the ground. Out for a ride, a cyclist pedals at a constant rate of 20 cycles per minute. Write an equation for this periodic function. So the maximum height is 30 centimeters above the ground, and the minimum is 8. So maximum and minimum. So then what I do is to find our amplitude and our K value, you need to find the middle of these two. So you can add them up and divide by 2. You get 19. And the distance from 19 up to 30, or 19 down to 8, is 11. So you have an amplitude of 11 and a midline, or a K value, of 19. Now it says that they are riding at a constant rate of 20 cycles per minute. So if it's 20 cycles in 1 minute, 60 seconds, that means it's 1 cycle every 3 seconds. So I found this to go down into seconds. And the reason I did that is because you've got 20 cycles in 60 seconds, right? That's multiple periods. We want to know how long it takes for just 1 rotation. So that's why I went from minutes into seconds and then just divided by 20 to determine that the period is 3 seconds. So it only takes 3 seconds for this cyclist to make 1 revolution on the pedals, and then you can solve for b. So 2 pi divided by b is equal to 3. That means the b value is 2 pi by 3. Now, in terms of writing your equation, you have to think about what this looks like. So you have a cyclist. Actually, I'm going to just draw only the top here. We don't need the lower quadrant. So we have a cyclist who's pedaling. Now the maximum is 30, the minimum is 8, the middle is 19, and we know in 3 seconds they're going to make 1 full rotation. Now when you go to draw this, the scenario here doesn't really tell you where the pedal starts. If the person was starting with the pedal at the top, you could draw it like this, where they pedal and it starts at the top. Or they could be pedaling and their foot starts at the bottom and then goes up and back down to the bottom. Or you could also have that they start in the middle and either go up, well, they would go up and then down. So here and then here. So you've got some options here. So when you're writing this equation, there's a bunch of different options. What I included here is definitely the amplitude of 11. definitely the b value of 2 pi over 3 and the k value of 19. But this could be written as a cosine graph, as a sine graph, and it could also be written as plus or minus for both. Now, yeah, because it could start either at the bottom, at the middle, or at the top, and it can go in either direction. So there's 4 different options laid out here. Of course, you could always write some of these with a horizontal translation. I don't recommend that. Try to avoid those when you can, but there's lots of different options here for answers. And the last one, this one gives you an equation and just wants you to graph it. So by using the averages of high and low tides, so tides in the ocean is another common application of sinusoidals, the depth of the water can be approximated by this function here, graph it. So this one, you're going to graph it just like all the others. What makes it a little bit trickier is just that you've got a lot of decimal values here, but still just think of the basics. You've got a k value of 13.4 and an amplitude of 2.5. That allows you to find your min and your max, and I've drawn those there. You have a b value here of 0.164 pi, so you can do 2 pi divided by this to get your period, which you can approximate to 12.2, and the shift is 1.5 to the right. So you'll see I started by drawing the graph in pencil here, that's without the shift, and then the shift 1.5 to the right, and you just move it as closely as you can. It's tricky when you don't have a grid. Just do your best to approximate it, and you have your final sketch. Now in this case, the only thing that I should have included here was that this was t, and this was d of t, so this is the depth, and this is the time.